Hello, my name is Victoria Kovac and welcome to my EL311 project demonstration, which is the Digital Medical Thermometer. My system is composed of two modules. The AC06 Bluetooth module on the printed circuit board, which is a slave device, and the Android application on the Android smartphone, which is the master device. The PCB contains a temperature sensor and some code, which allow for accurate body temperature measurements that are sent to the Android application via the AC06 module. The Android application receives and displays the temperature measurements as well as displaying them in a line chart as a way of record keeping. The main electronic components of my project are the MLX90614 infrared temperature sensor, the 0.96-inch OLED display, the Atmega 328P microcontroller, and the HC06 Bluetooth module. The temperature sensor and the OLED both use I2C protocol to receive commands from the Atmega 328, the master device, and to then send data back to the microcontroller. Communication between the Atmega 328 and the HC06 Bluetooth module takes place via UART serial communication protocol. The circuit schematic and layout were designed using the Eagle software. Here is the PCB layout. And then this is the manufacturing preview of my board. I also created a 3D model using Fusion 360 to visualize my board. As for the software, I use 5 libraries in total, including the Arduino Wire library, Adafruit libraries for core graphics, the OLED screen and the temperature sensor, and the software serial library for serial communication. The structure of my code is shown on the left, with the main portions of the code being the mode button, which changes the unit of temperature measurement from Celsius to Fahrenheit and vice versa, the measure button, which determines when the temperature measurements are made, and LED 3, which is the heartbeat LED and as such indicates that the microcontroller is operational. Further important features are the function measureTemp, which returns the arithmetic average of a number of sensor measurements in the appropriate unit based on the state of the mode button. For this project, I'm calculating the average of 10 measurements, which I store in Temp1 afterwards. Temp1 is then sent to the mobile application via Bluetooth along with a unit indicator, and it's also displayed to the OLED, which is indicated by the buzzer. Lastly, the boolean isBodyTemp variable checks if the temperature value stored in Temp1 is outside the normal range of 35 to 38 Celsius, which, if true, is indicated by LED 2. Despite not having encountered any hardware issues, I did initially have a problem with the function I wrote for LED 3. I used a timer to ensure that the LED blinks every second. However, since I was measuring the time in milliseconds, I exceeded the range of values of an integer after the timer's value reached 32,600 milliseconds. Using UART communication over a USB cable and the serial monitor in the Arduino IDE, I was able to detect this overflow and find a solution. I simply reset the value of the timer after 10 seconds, or 10,000 milliseconds, to 0, with the following if statement. The Android application I designed has 3 views. Firstly, the application can be used to assign different roles to users. In a hospital setting, for example, healthcare professionals can be assigned credentials to access and maintain body temperature records on patients. The Bluetooth connection view is encountered after sign-in, allowing the user to select and connect their thermometer to the smartphone in order to receive temperature data. Finally, after successfully connecting the thermometer, the application displays the connected device's name and the temperature it receives. A record is kept from the data sent over time and is visualized in a line chart. And here is my working project. The heartbeat LED can be observed blinking every second, and the buzzer sounds after Temp1 is displayed to the OLED as explained before. The frequency at which the buzzer sounds is controlled by the potentiometer. and LED 2 seen indicating a critical body temperature measurement of 33.21 degrees centigrade. And now with the Android application. Temperature data is received and displayed from the board every 5 seconds, and also when the measure button is pressed. Unfortunately, due to the pandemic and our university closing, I didn't manage to add the lithium polymer battery and its charger to my project like I had planned, in order to make my design flexible. I also would have liked to add a laser cut container to turn my thermometer into a medical thermometer gun. Further possible improvements to my system include adding a control feature to the Android application, for example for configuring the frequency of the measurements or the pitch of the buzzer. Thank you for your attention.